Yeah, well, welcome to the talk. Feel free to ask questions as we go along and shout out, because it's keep it fairly informal. So yes, Module 2 update, to cut to the chase, the current stable release is 1.82, which grafts onto 8.2.0. It also you can use a slightly less up-to-date version on GCC 6.4.0 or and also 5.2 and 4.7.4. And if you really wanted to go for legacy code, GCC 4.1.2, although that's a bit dim and distant in the past. But basically, we want the latest and greatest. It's 8.2.0. And that's kind of what I'm focusing on today. There isn't a huge difference between 8.2.0 and 6.4 in Module 2. Only in the right at the end of the talk it deviates. But anyway, so there we are. That's and I was tracking trunc until Easter, and then suddenly I think something happened at Easter. Maybe kind of read to, is it GCC 9? Vaguely, and at that point, trunc broke with GNU Modula-2, and I expect it won't be that difficult to fix. Famous last words, although never don't really know until I've opened the book, do you? But in the past, it doesn't take that long normally to bring Modula-2 into line with GCC. The exception to that was I think GCC 4.7.3. The step from 4.1.2 to 4.7.3 was huge. I think that was Gimple. but yeah, going from 6.4 to 8.2 was very, very simple indeed, if not trivial. Okay, so status. Finished implementing soft integer overflow for detection for addition, subtraction, negation, and multiplication. NaN runtime is detected, and third-party libraries can be added. Much of the code base is being reformatted to comply with the GNU coding standards, and that's kind of an ongoing thing. My major desire in the future is to push this into the tree. It's been way too long. That's the embarrassing bit. Thank you. Yeah, it must go into the tree, and everything else is secondary to that from now on. But the kind of fun thing about that is I've got to reformat some of the code and the GNU coding standards. I think it's about half done, and it's the C code that does the conversion between what the GNU Modula-2 front end does and the trees that GCC is expecting. Anyway, so release often, release early. I listen to your customers. One of Eric Raymond's famous sayings in the Cathedral and Bazaar. There's a number of these issues which came up in the last 2 years. Maybe resonated more with the last 2 years. This first one, I've heard about for the last 30 years, and I've always dismissed them until about April, and I confess. And the first one was new users always complain about the uppercase keywords in Modula-2, and I'm a Modula-2 guy, so I'm happy with. And of course, the generation where we used capitalization in the 70s and 80s, and that was not a problem. In fact, most of the code was written in capitals on teletypes, wasn't it? So this is not a problem for me. All the younger people, they say, oh, they don't like capitalized keywords. And I dismissed that for a long time. And I was chatting on the Modula-2 mailing list, and Benjamin Kawash came up with an awesome solution to this, which was to alter the IDE to write away. To render keywords in lowercase and maybe bold, underlined, etc., etc. But when you save the file, then it pushes it back into uppercase. So that suddenly this was solved. Now this has nothing to do with GNU Modula-2, so I'll quickly move on quickly, but and move over that. But only to say that there is an Emacs mode in GNU Modula-2, and one of the subdirectories there, which will do this for you. So if you really want, if that was an issue, it should no longer be an issue. The second one is to do with the compiler, and that is that one of the, I guess, attractions of lecturing is that you get to see new programmers grapple with languages. And they often, now the young people, have no fear, and then so they'll say things which is great, and so it kind of they say things that you probably wouldn't hear otherwise. And one of the comment in the classroom was when we're teaching code is why does the compiler, when I'm single stepping, why does the single step skip over maybe in C close curly brace, close curly brace, the case in this, and we know why, because the compiler's got rid of that code, you don't need to execute it. But for the student that's 2 weeks into their course, for them it's unnerving. They want a single step. I've written a line of code there. Why isn't the breakpoints, the single step going over that point? And so one of my colleagues said, almost like in a jokingly term, why don't you put a no-op at that point? And I thought, no, we're not making the compiler slower. And then I went home and thought about it. I thought, no, he's right. Let's do that. Let's put a no-op. Let's ensure that there is one instruction at every point. After a first-year programmers don't really care about speed, so and you can always turn it off if you don't want it. So, that was quite fun. And lastly, mature programmers complain that the compiler should be able to detect more runtime errors at compile time by utilizing its optimization knowledge, almost like a lint facility. And why can't it do that? If it's going to, and we'll look at some of those, and we have a plugin in Modula-2 which detects runtime overflow, some categories of runtime overflow at compile time. Okay, so. Yeah, we've been Benjamin Karash, which is great, and the idea has done that in Emacs, which is kind of fun, and we've done So this is the new option for Modula-2. This in the GCC 8.2.0, we have a new option -f m2 -g, which insists that at least one instruction will be issued for every statement keyword. Now, if there's already an instruction at that keyword, it doesn't create a new one. It does do it intelligently. But if there's nothing, then it'll insert a no-op. Well, and that's really easy. All it does, it generates a tree, a GCC tree, which is representing ASM volatile NOP. Now, that's fine, and that's trivial to do. The only thing is that I do ponder, and I'm not that well versed with all the different architectures. I know a few, but not many. But do all the architectures use NOP as no-op? And if they don't, it would be lovely if the back-end guys and girls could give me a machine-independent no-op.
There is an RTL pattern for no-op. So there's an RTL pattern for no-op.
Oh, is there?
Yeah.
Okay, thank you. Yes.
I don't know if it's mandatory that the backend implements the standard name for it.
Yeah, and it's probably not volatile, so it can be deleted by other parsers. So.
But so you think they can get to it?
I don't think every architecture calls it no-op. I think I remember there are test cases that use no-op, and I think some use a different. Some targets use a different name.
Right. Okay.
You could find it there by grabbing for an op.
Yeah, sure. Yeah. Okay, thank you. It is there. It exists. I shall have to look at that in more detail. Thank you.
If you need a volatile version of it, you could just create your own standard pattern and have that submitted. Right?
Okay. Right. Yes. Yeah. Sure. Right. Okay. So that kind of works. On an untuned AMD Black machine, 8-core, it actually ran 3% faster on two test programs with the no-ops. and I ran it repeatedly because I didn't believe my eyes. but
we know that some machines that have very wide fetch blocks or whatever, they don't like when they have too many of a certain instruction type close together.
Yeah.
And now with knobs.
Oh, okay, right.
Visual effects sometimes.
Yes. Yeah.
But this is with 0 probably. Yeah. This thing doesn't
amplify. Sorry. Yeah.
So there's measurements with 0 or 02?
Yeah, and that was 0. Yes. It was an untuned vanilla in GCC build on my AMD machine. So maybe if I use some weird and wonderful configuration options, it would have gone faster. But this is, I was surprised. I thought, well, they got this for free. Yes.
Actually, I think this old processor is very sensitive to instruction scheduling, and when you insert NOP, sometimes you improve schedule, and you can get a better performance.
Yes, yeah, sure. It must be something like that. Yeah. Okay. So let's look at this in action. Some light-hearted relief, really. This won't take long. And can't see what I'm doing. There we go. Okay, so this shows the excuse to show off the Emacs mode as well, actually, isn't it? The lowercase keywords. Yes. So this is without without the extra no-ops, and we're single stepping, and obviously the two ends at the bottom here at the bottom here, which will get ignored when we run the code. So here we are running the code, and do next. Yeah, and so it's skipping over the first end there. So, yeah, straight there, which should be unnerving maybe for a first-year student. And get the idea, etc., etc. Skipping over that one. Yeah, skips over the end again, and well, we get the idea. So yeah, I'll let it run to the end for the sake of completeness. Right. Okay, so that's fairly unsatisfactory. So let's try the extended. Same code again, compiled with the new option. Oh yes. Oh yeah. We'll go into the positive case of the then when we execute the then, and then I won't bore you with the rest of it. So in the middle, there we go, and then yes. So yes, we can see that. Yeah. So it's a lot of fun. Okay, so the runtime checking then, the Modula-2 standard specifies that it should detect quite a few runtime checking aspects. For example, index exception, range exception, you can read the list here, case statement exception, invalid location, that's nil, reference, function exception, not sure what that is off the top of my head, a whole value exception, that integer overflow, whole division, division by zero, again, real exception, that's a nan, and real division by zero, complex value, etc., etc. And some of these are library ones as well: sys exception, coroutine exception, exception. Some of those are to do with libraries, but the ones I want to focus on in this talk are whole value exception and implementing that. So the other thing that the 8.4 GNU Modula-2 did, it did implement real value exception. So it's a very trivial thing, but one of the one thing, well, it's a very, very trivial thing to implement. So after every floating point operation, it does detect whether the operand, the result is generated under nan, and if it does, then it calls the exception handler. And one of the users from, I think, from Europe wanted that, which is an easy thing to do, but it meant debugging libraries is rather nice. If you're doing a physics engine as well, it's quite nice, because often you get these kind of weird boundary issues which generate nans. You want to know where the nan came from. When we just put this flag on, or the switch on, and suddenly it'll tell you the line number and the operator that calls that. So it's trivial to do, but it's fairly useful. So then I guess I focused on whole value exception. Can you do the same for integers? Now integers is one thing, and that's probably a well-trodden route, but there is also subranges, which in Modula-2 we can declare, users can declare them as above. Here we have -1 to +4, which is a user-generated subrange. And what's happening here is that the code, it isn't actually the assignment that will cause the runtime error. It's the negate of x, obviously, because +2 to -2 is below the bottom, the min of the subrange, and therefore it causes an error. And so that should cause a runtime error. And how to detect that? Well, you have to detect you have to write code in GCC or GNU Modula-2 to detect the negate going overflowing or underflowing. And so in pseudocode terms, the negate would be as a sequence of tests, really. First of all, you're testing whether it's not 0, and you're testing whether the range is positive, whether the range is negative, and then and whether there is room to negate the type. So that's not that difficult to do, but you just have to remember all the different cases you're looking at. And that's converted into a sequence of GCC trees. I haven't shown the complete function here because it would be too messy, and if you really want the full thing, it's in the source code GM2 GCC GM2 M2 expression.c in the function check-all negate overflow. But the last few lines are just standards of trees that it's generating. But I guess the point to note is that it's making a call to an exception handler here. So if this final condition is held true, or results to true, then it'll call the whole handler, exception handler, and it passes this message in, and it also will pass the line number and the source file and the column number that's being used by which is generated the error. Right. So now once that's done, then we can just go back to our program again, and we can compile the code. And we can run the a.out, and lo and behold, it traps it and says the whole value about to overflow in whole value unary minus there. So at line number 9 in bar. So we can go down here, line number 9, and realize it's that unary that's gone wrong. Yes.
So you compile that with FM2G. Is that is this something that's only enabled when you compile them with that, or is this always happening? No,
this is separate. This is minus fsoft-check-all. So you can have these independent options. Yeah. So that's we handle negate, and now we can extend that obviously to look at add and subtract and multiply, and again. They're not that difficult to do. Again, you're looking for whether I is less than 0 or greater than 0, and then whether you can add whether there is room enough to do the increment without overflowing either the bottom or the top of the subrange. And so that's pseudocode, and here's the real code. This time the real code fits on one slide, so we can show that in its. I have trimmed it a little bit. There's a lot of qualifiers taken off here, which would make it ugly, but and to fit the left and right hand edges of the slide. But other than that, again, it's calling a handler at the bottom here, and we can pass in whole value plus if the condition should fail. So we know the line number, the column, and the source file, And we do this prior to evaluating, which is slightly neater, really. I mean, you could do it post, but I wanted to do it prior to the operation. Then you wouldn't have a result that you've got to throw away, and it's slightly cleaner to do it pre-op rather than post-op. And we can do the same for sub, which is really just a mirror image of add, and so I won't bore you with that. It's much the same. And we can also look at multiply, and the multiply case. Again, here we're looking at are the I and j both positive? The two operands that we're going to multiply together, are they both positive? If they are, then the test goes one way. If they're both negative, the test goes the opposite way. If one of them is positive, the other is negative, and then vice versa. And you've got the 4 different cases there. And you have expression trees which are converted into GCC speak, and we do that here. And again, it's calling whole value multiply should the condition be true. So what we have now is a little bit of test code. So we're going to compile with with -f soft-check-all, which turns on all the checks, so in the whole plethora of the Modula-2. All those will be checked, all those turned on, and all these here, including the ones in cyan color. Yep, so we're assigning I to 3, j to 3, and obviously the result will be 9, which exceeds 7, so we should get an error, and indeed, it tells us the line number. Gets the column number wrong, so I've got a bit of work to do there. But it's line 28. I think there's a GPL, the boilerplate at the top, which I've not put on the slide, which is line 28, but that is correct. And it says the particular operator that's caused the problem at line 28 at that point.
You could also print out the value that's overflowing, but that's probably wide. You possibly could do. Yes, that'll be interesting to do. Yeah, and that's
probably nice for users.
Yeah, it would be to I and j. Yes, yeah, that should, and maybe the subrange as well. That was the type. Yeah, you could go the whole. In fact, coming back to that, there's one of the other aspects of wandering around the labs behind the students. The students, I mean, these are good students. They got good jobs. They were one or two of them were saying they were choosing between LLVM and GCC based on the colorization of the errors. Yes. So although we would tend to maybe we would dismiss the beauty of error messages, it matters hugely to users. I mean, maybe it's obvious for him, but errors are important. So we could all, so well done whoever put colorization into GCC. Give them a pat on the back. So I'm really thankful to see that happen. That's happened. It's nice, isn't it? So we have implemented multiply, subtract, divide. Multiply, subtract, negate. I haven't done divide, I haven't done modulus, and those are to do, and I don't think they're particularly difficult to do. I suspect it's 2 weeks' work to do. But anyway, so going further with this, it would be possible, it should be possible to make the compiler detect some of these at compile time. Notice we're doing it at runtime, but currently. But if we knew that a function was reachable, and this were to occur in the first basic block of a reachable function, then we could use a plugin to detect the call to the exception handler, and then we could issue an error message at compile time, couldn't we? So that's one of the useful uses of plugins, and I wrote a tiny plugin to be plugged in at just after all the Gimple optimizations at star warn function no return. I used David Malcolm's awesome graphic to show the passes and whereabouts they are. No, it was actually a piece of gold dust. We're finding that on the internet, and I could see which pass and what was RTL, what was tree, and what was Gimple, and all that stuff, and color coded, and it was made to life. So I was figuring around for hours and rewriting code, and I've found this document, and it saved so much time. Anyway, so this is the snippet from the plugin, which is in the directory gm2 plugin rte.c, m2rte.c, and this is the function plugin in it, or part of it. You can see that's where we're placing the plugin, and this is the core of the plugin. It doesn't do much, and this again could be improved. It could do so much more, but currently it's still pretty useful, and you see it's pedagogically trivial, really. It's just running for every function. I currently look at every function that's being compiled, assuming they're all reachable, which is not true, but that's work to be done in the future, and it just looks for the first basic block here and checks whether the runtime exception is going to be inevitable, and if it is, it spits out an error message. Yes?
I'm just curious why you chose to use plugins here rather than just building this in as a warning pass to the compiler itself.
Well, I wanted to do it post-optimization.
Right.
Can you do warning passes from post-optimization? Probably can.
I don't know. I mean, that's something that you could consider talking to the global maintainers about, whether you could do something there.
Okay.
Just add your own pass. I mean, it's probably more maintainable that way, so they would probably sign off on something like that if you had a Modula-2 specific pass for this sort of thing. So
okay, yes.
It's worth considering.
Sure.
As you go. I mean, it's a great way to get it developed in the first place, but plugins are generally good for experimental stuff and so on, but eventually you just want them to be fully part of the compiler, I think. So.
Right, so using it as a warning pass is the way to go, you think?
Well, I don't see any reason not to. I mean, it's just off the top of my head, but I'm not a global maintainer. So.
Right, okay.
Warning pass does.
Sorry?
GC does have passes that are there purely to create warnings, like the initialize variable.
Right, and does that occur post-optimization?
I don't know if it's pre, but I don't know where that is.
Post and pre. Okay, if it
I
happens,
don't know if it's a fundamental design thing.
Because it would be nice to have it post-optimization.
I mean, suppose some people would not particularly like if your warning would depend on how aggressive your off flag is. But as long as it's not a warning that you sort of guarantee that it has to be there, as long as you make it clear that you may or may not get it.
Yeah, I mean, these ones, I'm happy that the optimizer can throw them away. Because if the optimizer throws them away, then they would never be executed. And therefore, the warning shouldn't exist, maybe.
For example,
but if it,
for example, it says like runtime exception inevitable. Well, that's probably an undecidable problem, right? So.
yeah, okay, yes.
So what exactly does inevitable mean there? That's kind of the decision you need to make.
Yeah, sure, yeah. Okay, well, I'll certainly take that on board and look at the warning pass. It may well be a cleaner way to do it, and it'll live longer. Okay, so then we have the test code. Go back to our test code again, and so it's pretty obvious what's going to happen if we can compile. And I have to put optimizer on, which is suddenly I'm coming around to your way of thinking, really, because without the optimizer, of course, the plugin doesn't fire. So, so I was thinking about maybe the users have to compile twice. They could compile with optimizing first, and then compile without optimizing. But that's probably not such a runner, really. But anyway, yeah. So with the optimizer, put it on and soft-check-all. We can see that line 28. It alters the error message, and it could do better here. It gives an error message, but it's lost some of the detail. But obviously it says inevitable that the error of this will occur at runtime. Expression will generate an exception as the whole value will overflow the range type, but it could do a lot more and tell you which operator is going to cause the problem. Okay, so future work and conclusions. There's clearly scope for improved messages. The technique works pretty well. It probably should be rewritten, as you say. That would be good. I need to complete div and mod, but that's a lower priority than getting it into the tree. Let's do the tree first, and then this will be background activity of div and mod. Modula-2, the detecting modulus of subranges is slightly harder. Well, it's not harder. It's slightly more verbose because in the different dialects of Modula-2, the negative modulus has different meanings. So there's multiple implementations to be done. But that's a matter of detail, isn't it? It would also be good to extend Modula-2 to use to embrace M2R10. I've been talking to Benjamin Kowash and Rick Sutcliffe, who have worked on M2R10, which is the 2010 new standard for, well, proposed standard for Modula-2, update, and in the spirit of Modula-2. And one of the easy things to do early, well, effective, not easy, but effective thing to do would be to remove variant records for, well, which is part of the M2R2 standard, removes variant records, but it introduces extensible records, and that would be a kind of an easy extensible thing to do first of all, and it would be a good way to start this work. Anyway, so yeah, and also thank you to all the GCC developers and the GNU Modula-2 mailing list community, because without that, this would not have happened. Thank you. So any questions? Yeah.
I just would like you to expand a little bit. I haven't followed the Modula-2 community, but in terms of what are the standards like? Is this an ISO standard?
There is an ISO standard, yes. Yeah, the ISO, and I didn't bring it with me. The ISO standard is about 700 pages.
Oh, that's pretty small.
Yeah, okay, yes. And compared to, I guess, the C++ modules, the Modula-2 modules looks incredibly clean, doesn't it? Qualifying imports, all that kind of stuff. And Wirth was a genius, isn't he? Yeah, but it's great stuff. Great to work with that. Yeah, there's PIM2, PIM3, PIM4, which the Wirth editions, which I think were around about, memory's hazy, around about 80. Gosh, I'm going to get this wrong now, but 81, 82, 84, and 86, but around about those dates. And 1990, 91, the ISO standard sat and produced the 700-page document, which is quite good. I mean, half of it is libraries, so Runtime, which has all been implemented. Half it's the compiler, approximately, and it's VHDM, I think, or VDM, beg your pardon. It's and also an English annotation. So it's a compiler's writer's dream, really, and you can read it all through, and it's all been implemented, I think, as far as I'm aware. Yeah.
So as part of that, what's the history behind the different dialects for the negative modulus and so forth?
Oh right, yes.
It seems like kind of a big hole in the language.
Yeah. Well, I think it was because of the hardware that the Wirth was targeting at the time. So the Ceres architecture, if I remember rightly, and the Lilith architecture, and another NS 32,000. And
both symmetric and truncating division are supported.
Right. Okay. Yeah. Well,
so you're really only supposed to do division on positive numbers. Then
okay.
Everything is okay.
Right. Yes. Absolutely. And all software writers, most software writers would only do that,
yeah.
because it's way too dangerous. In GNU Modula-2, you can specify, if you specify PIM2, PIM3, PIM4 ISO, you can specify any one of those, and you'll get the correct modulus interpretation of the language. You can also override it if we really wanted to and say, I want positive division or want negative division. But I mean, it's just, or ISO, which you can't override, I don't think, because ISO stipulates one way. And again, the nice thing about the ISO, it gets lots of test cases and it should behave. And so all those were in the Deja GNU test suite. And so I'm pretty confident. I had a bug report a couple of years ago saying what the modulus is wrong. So I'm pretty confident it's working now. I've absolutely hammered it out with lots of different test cases. Yeah.
Like in the C standard, division always rounds down, rounds towards 0.
Okay, runs to 0.
It should be always down, but it's always towards 0.
Right. Yes. So I've seen that you've got all this seal and floor and other stuff which I've been using. Thank you very much to implement all that stuff. Yeah.
So I fully agree with you and would like to encourage you to to get this into the tree.
Thank you.
I think the time
Yeah.
is ripe for that, and people should.
Yes.
You know, having more languages is a great thing for GCC. And
Yeah.
having them publicly up there. What are the current things that are stopping you from getting it into the tree?
Well, it's code formatting, I think. It's all GPL3. My employer signed an assigned future in 1996, so that's all good. That's all good to go. All the change logs that I've written most of it, and I had a couple of contributors from other people who have had GCC authorization. You know, they've done their all their paperwork's in place. So that's good. They were already contributors to GCC anyway, and so that's it. I need to reformat. I think my question is whether to produce a couple of patches which deal with the driver, the lang specs first, and then to dump a massive tarball which sits underneath in the tree GCC and then GM2. In the GCC folder and a bit GM2 folder or M2 folder, and everything sits underneath that. But there'll be probably a patch before that which handles all the specs, interferes with some of the spec and the linker aspects. I declare 3 functions, I think, which deal with the linking, which interferes with the object files being created. And so other languages would have to have, if you like, almost like dummy functions, so that they wouldn't, go wrong either. But
so does it work only on x86 or on?
No, it seems. I mean, I built a cross compiler for Atmel. That worked fine. ARM, it works on a Firefly. Yeah. Some guys going on the Spark. Yes, yeah.
Another question for including it into the mainline trees. Are there any tests?
Yeah, I got the GNU test. I got about
a lot of tests.
Yeah, I got
People are going to be really happy with it.
1,500 individual tests. They're run 6 times with the different optimization settings and compiler flags, etc. Yeah, and so
really nice because I really want more languages in the tree.
Okay.
To get more testing of stuff. Because there are a few things that are only tested by like one of the languages that no one uses. Right?
Yes, yeah, sure. And from my perspective, I would like it in the tree as well. I mean, for a number of reasons. One of the reasons that's come up very recently is that one of the users does a lot of testing. It uses Fedora Core, and said that the Fedora Core is deprecating libputh, and currently Modula-2 uses libputh for implementing coroutines. I just use the context switching, use it for the context create and context basically to map onto coroutines. And now I can easily move to another, but I wouldn't have known. And if it was, and I think they deprecated it, rightly so, because nobody was using it. But if this was in the tree, and of course they said, well, somebody is using it. I mean, thankfully they're using, I think, pith-sem, which is a superset of libpith. So it's not a big issue. But it's sort of think, this is a shame that it wasn't in the tree, because otherwise this would have been resolved, and it would have been more knowledge to make the decision, really. Yeah.
It's not a code formatting that's stopping inclusion in the tree, right? And because it's not important. The generic code should be looking just like everything, right?
Yeah.
But all of your own code, who cares, right?
Okay, right.
I don't think anyone cares.
Okay, right.
Yeah, I mean,
Yeah.
Are you working with a global maintainer at all about what it would take to get you into the tree?
No, I'm not. I need to.
That would be your first step, is you get with a global maintainer,
Okay.
develop a plan, and say,
Right.
what do I really need?
Right.
'Cause you're probably concentrating on things you don't have to do.
Yes.
to
Yeah.
get
Yeah.
upstream. They'll probably take it upstream the way it is. You've been very...
Probably are expert in getting things upstream. He really coaches new ports and all that stuff.
Say it again.
Sorry. I think Joseph Mars, he's usually an expert on getting used stuff upstream.
Okay.
So he
Right,
usually
yes.
knows all the little bits and pieces that need to be done.
Yeah. Sure.
On the formatting side as well, if you're creating a bunch of new files, I don't know if you look at a Clang format tool, it can pretty much just format the GNU stuff for you automatically.
Okay, right, yeah.
It's not perfect. There's some edge cases where if you have like really weird code, it might
it's
up and it reorgs the headers alphabetically, which is not what you want to do.
it's more the comments actually.
But it does pretty much everything for you, so you actually don't need to do anything.
Okay, yeah, that's good. Thank you. I'll look at that. Yeah. Thank you very much. Yeah.
I just listened to a presentation about the implementation models in C++. Actually, model are designed for this, for separate compilation, and it has it for more than 30 years.
Yes.
C++ people just starting to implement this. So I'm just curious, do you have any communication with Net and Sidwell about separate implementation of separate compilation?
Yes, Nathan emailed me last year after the Prague conference and asked me about the code.
It's implemented in Modula-2.
I did send him a URL of the implementation in Modula-2, but it probably would have helped. In a minor way, if he could just have a look at, just eyeball the code in the tree, wouldn't he? And said, "Oh, how does Modula-2 do it?" Well, that's how it's done.
Okay.
Yeah.
Thank you.
It's a pleasure. Yeah. Any other questions, or we're pretty done?
Just get it done.
Yeah. Okay. Fair enough. Yes.
So I didn't quite understand. It's a trivial question, but why do you dismiss lowercase keywords?
Why did I dismiss lowercase keywords? Probably because I'm old. and in the 70s, I was using a teletype, and Pascal handled lowercase, and Pascal could be uppercase or lowercase. So you had to use, in the teletype, you just had to use uppercase. Then there was occasionally you could use CRT, and you can use upper and lowercase. And I think Wirth, for Modula-2 chose uppercase. Probably because they couldn't render. Well, according to Benjamin, he thought it was because in the literature they would use bold lowercase, like in the Algol reports. And that was the kind of gorgeous way. In CACM journals they'd use, but of course the CRTs didn't have bold, the early ones. So they went with uppercase. And of course, for young, that was my first foray really into CRTs. I was seeing this. I thought, this is fine. All keywords should be in uppercase. And of course, suddenly it's a culture difference, really, isn't there now? But now, of course, we've got the mechanism with Emacs and whatever to have bold, italic, and all that kind of stuff. And so we can flip back to the CACMs of the 60s, if you like, and render that, and get away with it that way. But it's a neat idea, I think, of Get Benjamin's, and suddenly the code looks beautiful, I think. Yeah.
So it wouldn't create like ambiguities or anything if you...
No, because why don't we, if we got a bit of time, I'll show you that. Gosh, we can look at it. Yeah, so there's a symbol table code in Modula-2. And you can see that it's rendering the keywords with bold and underline. I've chosen that. Doesn't use an italic. And if I was to save this, or if I was to make a change, let's make a change like that, and then save it as it. Function keys. Now I've messed up. Okay, maybe I don't want to do that. Anyway, if I was to save the file, then it saved it, but lo and behold, if I scat it, then we can see that all the keywords are now in uppercase. So you've got the best of both worlds there. Yeah.
So the language is like trivial to parse?
Beg your pardon?
The language is like trivial to parse?
The language is?
Trivial to parse.
Yeah, sure. It's LAIR1, yes, and uses an EBNF grammar, so it's really nice and simple. Yeah, the only slight difficulty is that there's PIM2, PIM3, PIM4, and ISO, and so they all do have slightly different grammars. But thankfully, they're all compatible. I mean, so it's easy to do. Yeah, there's no conflicts. That would be awful, wouldn't it? Yeah.
I'm not familiar with the language Modula-2, except that I know there's a garbage collected language.
Okay.
Do you have interest in Modula-2, and if so, why? Or if not,
why not? I never really looked into Modula-2. I've got a book on my bookshelf which I've flicked occasionally, but it seems a very different language, but with very similar keywords. So I've there isn't a huge amount of overlap other than the keywords, I think. Yeah.
Yeah, that's interesting. I've never looked into it. I just was working with garbage collection many years ago.
Right. Yes.
Had Modula-2 at that point, and
okay.
that was one of the new languages using
yes.
garbage collection. So
The M2R10 is kind of perhaps maybe more fun, I think, is well, for me anyway. Yeah.
The which?
The Modula-2 release 10. Yes, which has extensible records, and so you can implement OO based on that. Yeah, and the other work they've done is that they've had almost like generics with the I/O, because one of the downsides of Modula-2s is the input-output. Although with GNU Modula-2 you can use printf, which is nice. From libc import printf, and it has var args, etc., etc. So that makes life a lot easier. But there is with Modula-2 R10, it uses like, I think it overloads a keyword, a key function which I've forgotten, rather like allocate and rather like new and dispose, and it maps those onto the particular methods of that particular type in a particular library. So you can have your own data type and then use this generic term, and it just generates all the calls to the various sub functions, which is kind of easy to implement as well. Yeah, sure.
So is there also a standard library for it, something like libc++?
There's a standard library for Modula-2. There's PIM, there's the PIM libraries, which are the Worthian libraries. Then there's the ISO libraries, which is about 350 pages of standard, and they've all been implemented. So they are very neatly designed, but they are different to anything else. Yes, but then there's in the tree there's also the University of Ulm libraries, which are GPL2, and they had a GNU compiler for about 20 years ago, I think, or 10, 20 years ago. But it only ran on the Spark. On the Solaris machines, but their libraries I've just taken over, shoehorned into GNU Modula-2, adapted slightly so that it maps with the underlying runtime system of GM2. Yeah. Okay. Yes.
So are there some big applications written in Modula-2 that use this that you're aware of?
There are two major users that I'm aware of. One is the ETH Zurich, who have 750,000 lines of code of climate modeling code in Modula-2, which is vast, isn't it? And then there's another company in the States which uses Modula-2 for ray tracing, I think, and computer graphics. And they were still shipping it to customers 2 years ago with GCC 4.1.2, and this is used daily, I think. Yeah.
So that brings me on to another. Those are both probably sound like heavily numerical codes. I'd assume that probably the numerical performance of stuff wasn't that good if you had all this checking on. Will they be doing stuff without any checking? Well, they can always turn it off, I suppose. But it's yes. I think by default it isn't on. But you can always put it on if needs be. It'd be interesting to know what the performance implications, degradation would be of detecting these things. Certainly with the physics engine I wrote, I think I ran it with a NAND detection, and I didn't notice it wasn't a massive degradation. It was still it ran in real time. It must have a few FPSs I lost, but it's probably when developing that's probably acceptable, I suspect. Yeah. Any other questions? No.
Thank you.
That's all right.